Hey there, welcome to NASA Launchpad. I'm your host, Amber Whalen. What does this, and this all have in common? Yeah, they're all satellites. But I'll bet you didn't get this one. They all use LIDAR instruments. LIDAR. Didn't see that one coming, did you? Now, I know we've kicked the term LIDAR around here on NASA Launchpad a couple of times, but we've never really gone into what it means. So, let's get that out of the way. LIDAR stands for light detection and ranging. Now, it kind of sounds like radar, right? LIDAR, radar, LIDAR, radar. Makes sense, since radar stands for radio detection and ranging. And the two are sort of similar in how they work. How do they work? Well, in the most basic sense, the system sends out a signal that is reflected by a target and then detected by a receiver. Sounds simple enough, right? And so far, a lot like radar. Well, there are some pretty major differences between radar and LIDAR, and I'm not qualified to explain those. So, let's check in with someone who can actually shed some light on the subject. Here's Dr. Russell DeYoung, Senior Research Scientist at NASA Langley Research Center, and he really knows what he's talking about.
LIDAR works by using a pulsed laser beam that is transmitted by a laser through the atmosphere to a distant target. Once it hits that distant target, some of that light is reflected back into the LIDAR system. In fact, we have a complete LIDAR system here. This is the laser transmitter, and it transmits a pulse of light represented by this bulb. The bulb or light pulse goes out in the atmosphere, bounces off an object, and some of that light comes back into this telescope. This is a large telescope, and at the end is a receiver which collects the light, and through timing mechanisms we can know exactly how far the light traveled and what time it came back, and as a result of that we know the distance of the far target from this data system. LIDAR and radar are similar in the sense that they use electromagnetic radiation. Now, LIDAR uses light frequencies and radar uses radio frequencies. And that's about the only difference, but the technique is the same. The advantage with LIDAR is that the wavelength is much shorter than radio wavelengths, and so in some applications you can get much better results in terms of measuring far distances and small objects and aerosols.
Cool. So one of the main things that LIDAR applications are looking for are those little things called aerosols. And when I say little, I mean little. Aerosols are tiny, tiny particles that are suspended in the air. They can either be natural, like little bits of ash from volcanic eruptions, sea spray, or dust storms. Or they can be created by people from burning fossil fuels or altering natural surface covers. Want to take a guess about how many aerosols are floating around you right now? Yeah, I wouldn't either. They're not things you can see by just looking, but you can study them with the help of LIDAR equipment. Here's Dr. DeYoung again with a more educated take on aerosols and LIDAR.
Suppose this is an aerosol particle in the air. Some of the light that comes from this laser hits this aerosol, and a small fraction of it bounces off the aerosol back into the telescope of this LIDAR. And as a result, we can tell what the density of the aerosols are in the atmosphere and also where they are in the atmosphere. And that's very important for health reasons because we breathe these aerosols that can have severe health effects. We know that within urban areas there's large amounts of aerosols in the atmosphere due to automobiles, exhaust, and road dust, and all kinds of both natural and man-made sources. And as a result of these concentrations build up, sometimes severely because of weather conditions, and then people start appearing in hospitals because of asthmatic conditions and all kinds of other ailments. And so it's very important to understand the density and where these aerosols are and how they transport from region to region.
But aerosol study is just one part of what LIDAR can do. As a matter of fact, LIDAR is used to study every part of the Earth's surface and even the surface of Mars. Have you ever seen a topographic map before? You probably have, you just don't know it. Topographic maps show lots of details, specifically in terms of relief or elevation, so you can see where things like valleys and mountains are. Do you see how LIDAR can be helpful in making maps like this? Alright, back to Dr. DeYoung to explain.
Because LIDAR can reach extreme distances and measure the conformity of ice sheets and landforms and ocean. So what we do is we put LIDAR in space and beam pulses down to the Earth and reflect off the Earth's surface, and then some of that light comes back into the telescope. And as a result, we can time the transmission of light from the laser to the receiver and get the ground profile of beneath us. And that's important because we want to know, for instance, ice sheets. Is the ice sheet growing or is the ice sheet receding? It's very important because that water is going to go in the ocean and raise the average sea level. So we get maps using LIDAR of all kinds of phenomena, from tree canopies to ice sheets to water levels to topographic maps of the Earth exactly. So it's a very useful concept.
And those are just a couple of applications from LIDAR. What else is going on with this technology? Dr. DeYoung?
Many applications of using lasers are going to be in measuring gases within the atmosphere, like ozone, carbon monoxide, carbon dioxide. All these constituents we need to know about because they impact our environment and our atmosphere and accelerate global warming, especially CO2. So in the future, you're going to see more and more lasers in space measuring the distribution of these important constituents of the atmosphere, like CO2.
Thanks, Dr. DeYoung. That's a lot to think about. And you, keep thinking about it. Can you come up with any other way that LIDAR could be used? Well, that's it for today. Thanks for watching. I'm Amber Whalen, and I'll catch you next time on NASA Launchpad. Hasta luego.